Today is the 28th of March 2024, and this will be our 16th video on trigonometry. Before I begin to tell you what I have to share with you today, thank you everyone who have subscribed to our videos, our channel. I appreciate it a lot. If you haven't considered subscribing and you like the channel, please can you consider subscribing, and let's share, let's like, let's follow. Please leave nice comments, okay? Leave nice healthy comments, okay? This is not a toxic platform. If the account is not yours, ask permission from the account holder before you use it to subscribe, okay? Don't use people's accounts anyhow. And in the comment section, you always see follow my notes/script. So for instance, these are a lot of numbers. I'll have to talk you through how I solved it, okay? I just can't take photos and just paste it. I need to show you the reasoning pattern I had to arrive at my answer, okay? So just follow the notes, okay? Please beware of scammers, okay? Beware of scammers, please. Recap: we did last lesson a lot of trick questions, but this time around, instead of bringing it in worded form, I just stripped it off and did the sketch and brought it to show you, okay? Because at times some people get confused if it's a lot of wording. So most of them were Pythagoras anyway. So I guess I took the wording out and then solved it and brought it out, okay? So I hope it helped you, and it helped you revise Pythagoras theorem as well. Today we are going to look at some interesting trigonometry questions, okay? For a while now, I've not been bringing different status with different status topics with what I'm going to share, because I just want to do as much questions with you in trig, so that you can raise your confidence in trig, okay? And then to know how to apply the right function, to know which formula to apply, okay? So with the status, I just bring in trig questions anyway. So here, the first example, we have a right angle triangle, okay? And then we have x, y, z, and then they said we should find yz here, okay? So how do we find yz? We have to use Pythagoras, okay, because yz is the hypotenuse. So yz all squared will be equal to 3.2 all squared plus 1.7 all squared. In the end, I'll bring my units. So yz all squared, 3.2 all squared is 10.24. 1.7 all squared is 2.89, which will be equal to 13.13. Okay, so yz is plus or minus the root of 13.13, which will give you 3.6. centimeters to 1 decimal place. Now these diagrams we've been using, they are not to scale. Okay, they are not to scale, or they are not drawn accurately. I haven't measured them. I've just used the ruler, drawn it out just for you to see. Okay, and if it's to scale, I'll tell you. Now there's another example here I want to show you. Now we learned how to use the sine rule. A over a sine A, B over sine B, C equal to C over sine C. Okay, so the angle at A, then you use the length opposite A. Angle at B, use the length opposite the angle at B. The angle at C, you use the length opposite at B, and we said that the flip side is also true. So sine A over A, sine B over B equals sine B over B equals sine C over C. This is why you should follow my notes, okay, because I'm missing the equal to sign. So here, so x is divided by the sine of 70 should be equal to 9.1 divided by the sine of 38. Okay, so if you are able to set that in motion, the rest is calculation. Okay, so applying sine rule, this rule here, x divided by the sine of 70, okay, and then should be equal to 9.1 divided by the sine of 38 degrees. Okay, so x now will be 9.1 divided by 38 times sine 70. Okay, so x equals to 9.1. The sine of 70 is 0.9397, all divided by the sine of 38, which is 0.6157. So if you use the calculator right, x will, the numerator 9.1 times 0.9397 will give you 8.5513, all divided by 0.6157. Then you use the calculator right, you get 13.89 meters. This is to 2 decimal place. X is a length. Okay, that is a meter, so S will be in meters. So S will be 2 decimal places 13.89, or 1 decimal place 13.9, or the nearest whole number 14 meters. Okay, if they don't restrict you, you can leave it. You can give any of these 3 answers, but immediately they restrict you to the nearest whole number, or 1 decimal place, or the square root, okay, or the nearest 2 decimal places, or 2 significant figures. You have to follow the rules. You have to do that, okay, otherwise you lose marks. Okay, so that is the first applying sine rule. Then we are going to look at the second one as well. This is our diagram, again not to scale. So applying sine rule, as I just told you, 6.7 and then you use the angle opposite. So 6.7 divided by 1 sine 112 should be equal to 4.3 divided by sine x. Okay, or you can do sine x divided by 4.3 should be equal to, because we are finding x, should be equal to sine 112 divided by 6.7. The rule here is, if you are going with the length in the numerator and finishing with the angle in the denominator, then you do the same for the other side. You start with the length, finish with the angle. Okay, don't start with the angle, finish with the length, then you equate it to the length. No, you don't do that. So if you decide to use the length on the numerator and the angle denominator, then you have to do the same for the second one. Okay, so immediately you set that into motion, you've applied sine rule. So now sine x divided by 4.3, okay, will be equal to sine 112 divided by 6.7. That is the diagram we are using. So sine x will be sine 112 divided by 6.7 times 4.3, that one, and it's in centimeters. Okay, so sine 112 is 0.9272 times 4.3, all divided by 6.7. So now everything now is calculation. So sine x, from what we did, so the numerator becomes 3.98696, okay, divided by 6.7, and then you get 0.5951. X will be the sine inverse of 0.5951, which is 36.52 degrees. Okay, to 1 decimal place is 36.5 degrees. The sine is an angle, so you are going to leave it as degrees. Okay, it's not the length, so you are going to leave it as degrees. Okay, now our third example is trigonometry in 3D. So before I share that with you, okay, I'm going to show you something. Assuming this is a cuboid, okay, assuming this is a cuboid, look carefully. I was looking for a proper box, but I didn't find it, but this will do. So assuming this is a cuboid, A, B, C, D, okay, E, F, G, H, okay. Assuming that is a cuboid, okay, this length here should be equal to that length here, that length here, and then that length here and that length here will be the same. Okay, so if they tell you this is 5 centimeters, then that will be 5, that will be 5, and the length there will be 5 as well, that one. This length here, that length here, that length here, and the length in there will be the same. Okay, the height here and the height here and the height here and the height here will also be the same height. So if they give you the length, the width, and the height, then it's a cuboid. So it means you can transfer all of that. Okay, I'm talking about trig. So if you know this length and you know this if you know this length and you know this width, then you can find the diagonal from here all the way to there. Okay, you can find that, but you've been given the height. So if you know the diagonal there and you know the height, okay, you can create another right angle triangle that way. Okay, that way. Let me show you with this. Another right angle triangle that way here. Okay, so now because you found the diagonal, okay, using this width and the length here, okay, you found that length. Now you can create another right angle triangle with this diagonal you found, with this height here, and with this pencil I found, and find the angle here. Okay, this is like trig in 3D. So I'm going to use that thinking to solve the question I have with you. So we are supposed to find the angle here. Okay, this angle here. So first of all, I'm going to use this width and that length to find, use Pythagoras to find the diagonal here. And then whatever I get for this, I already know this one here. Okay, so I'm going to use the right function to find the angle, because immediately I put my pen here, I can do from there to there, up here. That will be my right angle here in the corner here. And then with my pen joining here, I can create an angle here. So if I know this length, okay, which I'll use this side and that to find, and I've been given this height, then I can use the right function to find this angle. So basically, that is a trig in 3D. Okay, so I'm going to show you the question I have. Okay, so now consider the cuboid. Okay, so it's trig into it. So I've just shown you. Okay, next time you get a parcel and it's a cuboid, have a good look. Okay, don't just throw it away. Put it down for 3 days. Keep on looking. Okay, so here I know what they've given me, the length of the cuboid as 12. Okay, and they've given me the width as 5. Okay, and then I have this one here as 5. Okay, so what I'm going to do is I'm going to use 5 centimeters and 12 centimeters to find this length here from this corner H to that corner, because we are supposed to find the angle DFH. So this is A, B, C, D. Okay, then we have E, F, G, H. Okay, so I'm supposed to find the angle here, DFH. So D, F, and H. Okay, so I'm going to use this 12 and that to find the length here. Okay, and then when I do that, now that I know this length and I know this height, then I can connect D to F. The angle here is what I'm supposed to find. I hope we get it. Okay, so now HF, okay, HF, the diagonal, okay, will be all squared, will be equal to 5 all squared plus 12 all squared. Okay, so I've set the equation in motion. Immediately you do that, that part becomes calculator. So 5 squared will be 25, 12 squared will be 144. If you add it, you get 169. So the square root of 169 will be equal to HF, which is 13. So if this is 5 and this is 12, then from this corner to that corner here is 13. So that is what we've just done. We've used 5 and 12 to find from here to there. Okay, from here to there. So from all this side we have done that. Okay, but we know that from here to here is 5 centimeters from our diagram. So if we know 13, this will meet at right angle in that side. So if I put my pen here this way, it's going to create an angle there, an angle here. Okay, so I can use the right function to find the angle. So now let's go on. So we found the diagonal this side. We found the diagonal this side from here to here. Okay, and that is 5. We want this angle, so we know the opposite. Okay, and we know the adjacent, so it means we are going to use tan. The opposite is 5 and the adjacent, which is the one we found, is 13. So the angle DFH, this angle here that we are supposed to find, DF and H, okay, equals the tan of that angle at DFH, which will be equal to the opposite 5 centimeters divided by the adjacent to the angle 13. So that is what we have. 5 over 13 will give you 0.3846. Okay, so the tan inverse will give you 21 degrees. So this angle here is 21 degrees. Okay, so the next time you get a box, don't be quick to throw it away. This is like trigonometry in 3D. Okay, if you look at it carefully, you can do it. Okay, don't look at the question, as I've always said, and get intimidated. Okay, if you can, that's why at times it's good to sketch, because sketch the diagram, because sketching will show you. Assuming they gave you the diagram, you have to visualize what I've told you. Immediately you can find a diagonal, then you can create another right angle triangle. Okay, so when you get a box from delivery next time, keep it. Okay, keep it for like a day or two, and just try and visualize these things. So first of all, you use this and that to find this length here, and then use the height, the right function which you found to be tan, to find the angle, which we did. So the angle is 21 degrees, because 5 over 13 is 0.3846. So you press the second function, press tan, okay, and then to give you the angle. Okay, so this is what I came to show you today. So I'm going to show you the diagram again. Have a very good look. Okay, the angle here is what we are finding. Okay, and yeah. Okay, so please subscribe. Okay, share, like, follow, do what you can so that we can just be on the community, in the community. Okay, and if the account is not yours, please ask permission or open your own account. If you can't, ask somebody to help you. Beware of scammers. Okay, thank you very much for watching today's video with me, and I'll see you in the next.